Okay, 6.2, radian measures and angles in the Cartesian plane. This is a summary of grade 10 and grade 11 trigonometry. We're going to summarize some of the algebraic portions of trigonometry, but working in radians. So a few things just we're going to convert. We have always dealt with special triangles. We know the special triangles. There's two of them. Right? Those special triangles are 90, 45 degrees, and 45 degrees. And then 90, and then there's 60 degrees and 30 degrees. What we are going to do now is to convert them into radians. So what is the radian equivalent of our special triangles? Well, we know instead of 90, it's pi over 2. Instead of 45, it's pi over 4. And for our second special triangle, once again, this is pi over 2. The 60-degree angle then becomes pi over 3, and the 30-degree angle becomes pi over 6 radians. Now, these two triangles are meaningless without the side lengths, so let's go ahead and fill those in. The 45, 45, 90 triangle has side lengths of 1, 1, and then if you use a Pythagorean theorem, you would get the hypotenuse as being root 2. So the pi over 4, pi over 4, pi over 2 triangle will also have side lengths of 1 and 1, and a hypotenuse of root 2. For the 30, 60, 90 one, it's going to be 1, root 3, and 2. So again, it'll be 1, root 3, and 2. So across from 60 degrees is root 3, across from 30 degrees is 1, and across from 90 is 2. So we apply the same thing for pi over 3, pi over 6, and pi over 2 to figure out what our second triangle is going to be. These two triangles, you should have it memorized by now. If you don't, take a little while to review them so that you have it memorized. I would strongly recommend when you do questions, draw these on the top of every single one of your page so you get into the habit of writing it down and you get that muscle memory, and then you'll remember what they're supposed to be. Now we're going to look at another concept, which is the angles that are created by points on the Cartesian plane. So if I was to draw this point or plot this point on the Cartesian plane, it'd be -4, +3. That would be my point, -4, 3. And the angle that's created is always with the x-axis. So this is the angle. Let's go ahead and label what we know about this angle now. This is 3 units up, so this is 3. And this would be 4 because you went 4 to the left, but it's still 4. It's 4 units across. Now, if we were now to look at our primary trigonometric ratios, so sine of theta, cosine theta, tan of theta. Right before we finish, let's find the hypotenuse. If we use a Pythagorean theorem, it'd be 3 squared plus 4 squared is equal to 5 squared. Sine theta is opposite over hypotenuse. So the opposite is 5. So sine theta would be 3 over 5. Cos theta is 4 over 5. And tan theta would be 3 over 4. What we want to understand now is that this can be applied to any point. What I'm going to change is instead of -4 and 3, I'm going to label my points as something else. I'm going to say the point is x and y, meaning it can be any x value and any y value, and when you put them together, the x value would be here at the bottom, the y value was here at the top, but we're going to switch it to be x and y only. So y, x, and then there is going to be your hypotenuse, but we call it the radius. So if we switch it around, sine theta is now y over r. Cos theta is x over r, and tan theta would be y over x. And you can use this with points that are given to determine what angle would be created. So another way to represent the relationship between the points and the angles that's created is to look at something called a unit circle, right? And this is, in my opinion, it's only beneficial for 4 or 5 key points. The unit circle, right, goes around and it has a radius of 1, right? So all of these points are at 1. So that point is 0, 1. That point is 1, 0, negative 1, 0, and 0, negative 1. Now, if we were to find the angle at each of these points, let's take an angle at this point, right? So if we went across like this, and it's 90 degrees. Well, I know that, for example, cosine of pi over 2, cosine is going to be x divided by the radius. Well, for this one, x is 0, and the radius is 1, so it's 0 over 1, and we know that cosine of pi over 2 would be 1. If we want to find tan of, let's take pi, right? We want to find tan of pi. Tan is y over x, so y is 0 over x is negative 1, so 0 over negative 1 would be 0. This is where this can be beneficial, and really it's the biggest benefit is at 0, pi over 2, pi, 3 pi over 2, and then back again at 2 pi, which is the outlines for your Cartesian plane, your circle. Okay, let's do some examples. We're going to start with example 2. It says determine the exact value of each of the 2 trigonometric ratios. So the first one is sine theta, or sine of pi over 2. Now remember, when the question says find the exact value, we should not be using our calculators. We should be using our special triangles. There should be no rounding going on, because as soon as you punch something in your calculator, you get a decimal, you're going to have to round that decimal. So we don't want to do any decimals. We don't want to do any rounding. What we'll start with is sine of pi over 2. Now, remember that pi over 2 is 90 degrees. So if I was to draw 90 degrees here, that would be 90 degrees. So there's my point. Well, if that's my point and I take a unit circle, it's 0 and 1. Now, if we go back to what we just looked at, sine theta is always y over r. So if x is 0, y is 1, and the radius r is also 1, sine of pi over 2 would be y over r, which is 1 over 1. So sine of pi over 2 is 1. Let's go to the second one, which is cotangent of 3 pi over 2. So cotangent of 3 pi over 2. Okay, again, 3 pi over 2, if we were to take a graph of 3 pi over 2, it would be all the way around. It would be this line. And this point here would be 0 and negative 1 with a radius of 1, right? The radius is 1. So cotangent would be the reciprocal of tangent. And we know that tangent is y over x. So cotangent would be x over y. So which would be x is 0 over negative 1. So cotangent of 3 pi over 2 would be 0. Okay, let's look at example 3. It says determine the exact value again of each trigonometric ratio. So now we have cosine of 5 pi over 4. If we're going to find cosine of 5 pi over 4, we need to determine a few things. I'm going to show them on the board, but really you can do them in your head because you want to be able to just summarize what information is given to us. So cosine of 5 pi over 4. 5 pi over 4 is greater than pi, so it's going to be in quadrant 3, right? So this would be 5 pi over 4, but it's less than 3 pi over 2. So if it's greater than pi but less than 3 pi over 2, it's going to be in quadrant 3, and that means that cosine is negative. So I know this is going to be negative. Next, I want to find the related acute angle for 5 pi over 4. to find the related acute angle, which is this angle down here, I would take the whole 5 pi over 4 and subtract pi. 5 pi over 4 minus pi. So I can make that 4 pi over 4, and I'm left with pi over 4. So it becomes negative cosine pi over 4. Now cosine of pi over 4 goes back to my special triangles. If you remember, cosine of pi over 4 would be the adjacent is 1 and the hypotenuse is root 2. So it's negative 1 over root 2, and there would be your answer. Now I'm going to introduce a concept called rationalization, because this is considered to be a radical because there's a square root in the denominator. In order to move this up, what you'll see in the textbook is that they'll multiply the numerator and the denominator by whatever will eliminate the square root in the denominator. For example, if I did square root of 2 times the square root of 2, I'll be left with root 2 times root 2 is root 4, and at the top, root 2. Now root 4 is the same thing as 2, and I have root 2 over 2. So 1 over root 2 is the same thing as root 2 over 2, and oftentimes you will see sine of pi over 4 or cosine of pi over 4 represented as root 2 over 2. So cosine of 5 pi over 4 is negative root 2 over 2, because 5 pi over 4 is in quadrant 3. Let's look at the next one. Cosecant of 11 pi over 6. Same thing. Step 1, we're going to determine which quadrant 11 pi over 6 is going to be in, and then we're going to figure out our related acute angle, and then we'll figure out what is the special triangle ratio that goes with that related acute angle. Quick tip: if the denominator is 3, 4, or 6, to find the related acute angle, it's always pi over that number. Here it was 5 pi over 4, the related acute angle is just pi over 4. There's 11 pi over 6, the related acute angle will be pi over 6. 3, 4, and 6 are your key angles from your special triangles. The related acute angle will always just be pi over 6 or 3 or 4. So let's figure out which quadrant 11 pi over 6 is in first. So 11 pi over 6 is definitely more than pi, but it's also more than 3 over 2 pi. I know that because 3 over 2 pi or 3 pi over 2 is 1.5. But 11 pi over 6 is going to be less than 2 pi and greater. So it's going to be in this quadrant here. This will be 11 pi over 6. In quadrant 4, I need to figure out what is cosecant. Cosecant is the reciprocal of sine. So sine in quadrant 4 is negative. So I know my answer will be negative. And then cosecant of 11 of just pi over 6, because what's the related acute angle? It is just pi over 6. Now, cosecant pi over 6 is the reciprocal of sine pi over 6. Sine of pi over 6 is going to be, again, it's going to be 1 over sine pi over 6. Sine of pi over 6 is going to be 1 over 2. And the reciprocal of that, you just flip the 2 and it becomes negative 2. And that would be cosecant of 11 pi over 6. This does take some time to get comfortable with. It does require you to sit and do these questions. Organize your thoughts. Step 1, when you're coming up with questions like this, step 1, determine which quadrant your answer is in. Step 2, you want to figure out, is that trigonometric the trigonometric ratio, is it positive or negative in that quadrant? Step 3, find the related acute angle. And then step 4 would be to solve that related acute angle ratio using your special triangles.